inclination of a plane in a space, Number 3, comparison between gradients and comparison between the gradients of a function of two variable and function of three variable. These three things we will discuss in this section. So sorry, I am using the Zoom board. That's why it is not working properly. So I am going to the whiteboard for students. Now can you see? Students, captains, can you see my screen?
No, sir.
No, sir. No screen is shared.
You cannot see?
No, sir.
No.
I'm facing some problem. I cannot share the my okay. So now we know that if a equation of a surface in a space, primarily we know that it is denoted by z equal to f of xy. F of xy. So now if we write this equation like f of xy minus z equal to 0, and later we can denote it f of xyz equal to f of xy minus z equal to 0. So then look at that. This is the function having 3 variables, and this is the function having 2 variables. So that's why when we have this type of 2 variable function where z is the dependent variable and xy is the independent variable, then we can convert this function in a 3 variable. And the same thing we did for the level surface. So let us for an example. Now can you see? Marin, can you see?
Yes, sir, we can see.
Yes, sir.
Okay, so let f of xy equal to x square plus y square plus z square minus 4. Minus 4. So then if we want to find out the level surface, then we can write it xyz equal to 0. That means the level surface is given by x square plus y square plus z square minus 4 equal to 0. So now we should determine the sphere. Look at that here. This is the equation of a sphere whose radius is 2. Whose radius is 2. And center is 0, 0. So now we'll go for what does it mean by the tangent plane and normal line to a surface. So go to the new page. So normal lines are equally important in analyzing the surfaces. For example, let's say to consider the collision of 2 billiard balls. Consider the collision of 2 billiard balls. When a stationary ball is when a stationary ball is struck at a point, at a point P on its surface, then it moves along the line of impact, determined by P, and the center of the ball, Look here, let's say this is a billiard ball, and it is attacking by or struck by another ball, and along this direction, then this is the, look at that, this is stacking upon the red color ball, this ball along this line. This is called the line of impact. This arrow sign is called line of impact. Okay, so after the collision, the red color ball then again going to this direction, and at that time the stationary ball, that means this ball, stationary ball, will go this direction, and this is the line of collision, and the direction of this red color ball is called the line of impact. It's called line of impact. So this line of impact is called when the cue ball is not moving along the line of impact, it is deflected to one side or the other and retains part of its momentum. So the part of the momentum that is transferred to the stationary ball occurs along the line of impact, regardless of the direction of the cue ball. Let's say this is a ball and this is a stationary ball. So after the collision, let's say, so this is the direction of the stationary ball, and this is the direction of the billiard ball, and so this line is called the line of impact. So this line of impact, is called is called the normal line to the surface. Normal line to the surface at the point where this is the point where it is occurring. This is called the P. At the point P. So now in the progress of finding a normal line to a surface, finding a normal line to a surface, to solve the problem of finding a tangent line. A tangent plane to the surface. So let S be a surface. S be a surface given by f of x, y, z equal to 0 and p x naught, y naught and z naught is a point on S. So now let C be a curve, curve on S, throw P, that is defined by the vector valued function R of t equal to xti plus ytj plus ztk, where t is the parameter. So then the equation of the surface can be written equation of the surface can be written f of xt, yt, zt equal to 0. So now if f is differentiable, if f is differentiable, f is differentiable and x prime t, y prime t, and z prime t all exist, then it then we can write f prime t equal to 0. Do you understand how can we write it, everybody? Do you
Yes, sir.
understand? Okay. So instead of that, we can write using the same rule. Using the same rule, we can write f of x, x, y, z, x prime t plus fy, x, y, z, y prime t plus f of z, x, y, z into z prime t equal to 0. So it can be written based on the using the vector notation. It can be written nabla f x y z dot r prime t, because you know that r was the vector valued function of x t, y t, and z t. So if you determine the dot product between the gradient vector of capital F and the radius vector r, then you will get this upper line. Any confusion, anybody? Any confusion?
No, sir.
No, sir.
So this is called gradient. Sorry. This is called gradient, and this is called tangent vector or radius vector along the tangent. So now if we want to determine this at any specific point, so can I go to the next page?
Yes, sir.
Okay. So at any specific point, so at a specific point x naught, y naught, and z naught, the vector for equivalent vector form is nabla f of x naught, y naught, z naught dot of r prime t naught equal to 0. Equal to 0. So this result means that this result means that the gradient at P is orthogonal to the tangent vector. Is orthogonal. Orthogonal to the tangent vector of every curve on S through P. Do you understand why I am telling this is orthogonal? Do you know what is the condition to be orthogonal? Everybody, do you know what is the condition to be orthogonal? Can you hear me?
Dot product has to be 0.
Yes, sir.
Mary,
Yes, sir.
Yes,
do
sir.
you know why I am telling this is orthogonal?
Sir, dot product has to be 0.
Yeah, if dot product between two vectors are 0, then we are telling that this is the orthogonal. So that's why we see that this is a dot product and the result of this dot product is 0. So that's why the gradient, we can say that this is the gradient part. So gradient is orthogonal to the tangent vector of every curve on S at point P.
Yes, sir.
Okay. So that's why we can summarize the system. That means definition of the tangent plane and normal line. Can I go to the next page?
Yes, sir.
Now, that's why we can say the definition of tangent plane. Definition of tangent plane and normal line. Normal line is, we can write it like this. Let f be differentiable at the point P x naught, y naught, z naught on the surface S given by f of x, y, z equal to 0, such that the gradient is non-zero. That means capital F of x naught, y naught, z naught not equal to 0. Then the plane through P, number 1, plane through P, that is normal to gradient, that means f of x naught, y naught, z naught is called the tangent plane. Tangent plane to S at P. And number 2, the line through P at the direction of nabla f of x naught, y naught, z naught is called the normal line to S at P. Do you understand what is the difference between tangent plane and normal line?
Yes, sir.
Okay, so now can we go for the next page?
Yes, sir.
Okay, next. To find an equation for the tangent plane, equation for the tangent plane to S at the point x naught, y naught, z naught. Let x, y, z be an arbitrary point. In the tangent plane. Then the vector v will be x minus x naught I plus y minus y naught j plus z minus z naught j lies in the tangent plane. Lies in the tangent plane. Do you understand? Any confusion?
No, sir.
Okay, because gradient of f of x naught, y naught, z naught is normal to the tangent plane. Normal to the tangent plane at the point x naught, y naught, z naught, and it must be orthogonal orthogonal because this is the normal. Orthogonal to every vector. Every vector in the tangent plane. In the tangent plane. So that is we can say that gradient of f of x naught, y naught, z naught dot any vector v equal to 0. So can I go to the next page?
Yes, sir.
Okay. So from the above discussion, we have if f is differentiable at x naught, y naught, z naught, then an equation of the tangent plane to the surface given by f of x, y, z equal to 0 at x naught, y naught, z naught is f of x into x naught, y naught, z naught, x minus x naught, because one that time vector v was x minus x naught I. F y x naught, y naught, z naught, y minus y naught plus f of z x naught, y naught, z naught into z minus z naught equal to 0. So this is the equation of a tangent plane. Any confusion?
No, sir.
Okay, so now we can go for an example. Find an equation of the tangent plane. Find an equation of the tangent plane to the hyperboloid. That means surface is hyperboloid. To the hyperbolic z square minus 2x square minus 2x square minus 2y square equal to 12 at the point 1, -1 and 4. So let us see the solution. So based on the theory, so at first we should determine. So from the given equation, we have z square minus 2x square minus 2y square minus 12. Let's say this is capital Fx, y, and z. So next, we should find out the derivatives with respect to x, derivative with respect to y, derivative with respect to z. So can I go to the next page?
Yes, sir.
No, sir. One minute, please.
Any question? Anybody are asking something?
No, first to wait to change the slide.
I cannot hear you properly. Maybe my sound system is not working properly. So can you tell me again any question if you have? Marin?
Sir, I think
Jasmine?
Shukra was trying to say that you should change the slides a little bit slower.
Oh, okay, okay. Okay. When you will agree, then I will change, otherwise not. Okay, if you complete, then tell
Yes,
me.
please, sir. Finish.
Okay,
Sir.
now I'm going. So now, so from f of x, y, z equal to 0, fx, that means differentiation with respect to x. Then look at that, the first term is z, so that's why it should be 0, because we know that first term was capital F was z square minus 2x square minus 2y square minus 12. So that's why if we do with respect to x, then it will be only the minus 4x. Am I right, everybody?
Yes, sir.
Similarly, fy with respect to y, then it will be minus 4y. Similarly, f of z, that means with respect to z, then it would be 2z only. Okay, so what was the point we were asking to determine the tangent plane. What was the point?
1 minus 1.
Can anybody tell? At the point 1 minus 1, 4, it was given the partial derivatives are, that means fx at 1 minus 1, sorry, minus 1, 4, it was minus 4x, so that's why it should be minus 4 f of y 1 minus 1, 4, so it was minus 4y, so that's why it should be only 4, and f of z at 1 minus 1, 4, it was only twice z, so that's why it should be 8. Any confusion?
Oh, sir.
Okay, so now equation of the tangent plane at the given point 1 minus 1, 4 is based on the theorem. It was fx x minus x naught, fx 1 minus 1, 4 into x minus x naught plus fy 1 minus 1, 4 into y minus y naught plus f of z 1 minus 1, 4 into z minus z naught equal to 0. Now plug the values. So fx was minus 4 and x minus x naught, that is x naught is 1. Fy was 4 and y naught is minus 1. So that's why it should be y plus 1. F of z was 8 and z minus z naught was 4. So that's why multiply 4x plus 4 plus 4y plus 4 plus 8z minus 32 equal to 0. So finally we will get minus 4x plus 4y plus 8z minus 24 equal to 0. That is, so the required equation is x minus y minus twice z plus 6 equal to 0. This is the equation of tangent plane. Any confusion?
No, sir.
Okay. So if the, now can we go to the next page? Complete. If you agree, then I will go. Now, can I go to the next page?
Yes, sir.
Yes, sir.
Okay. So now if the function is two variable, that means so now if the function is, that means two-dimensional, f of xy equal to 0, then the equation of tangent plane will be f of x, x naught, y naught into x minus x naught plus f of y, x naught, y naught, y minus y naught, f of z, x naught, y naught. Sorry, do we have any z? Sorry. Do we have any z? We have only the two types of variable, x and y. So now if we write the function, like f of xy equal to z, then we can write it f of xy minus z equal to 0. So that's why on that time the tangent equation will be z minus z naught, because z is here dependent variable. So we cannot do the differentiation with respect to the dependent variable. We can do the differentiation only with respect to the independent variable. Okay. So next we will go for the angle of inclination of a plane. Angle of inclination of a plane. This is also determined by the gradient. These are the applications of the gradient. So the definition of the angle of inclination is the angle of inclination of a plane is defined as the angle theta, where theta lies between 90 degree to 0 degree. Between the given plane and the XY plane. XY plane. So I can show you here. Let's say this is three-dimensional space. This is Z-axis. This is Y-axis. This is X-axis. So let's say this is XY plane. This is the XY plane. This is XY plane. I can give you the this is XY plane. This on. Now another plane, if we take with this on, let's say that is this on. This is another plane. We will determine. Then this is the angle. This angle is denoted by theta. And based upon the angle, look at that, upon the angle, let's say this is the direction of the plane. Then this is 90 degree. This is the normal to the plane. That's it. That since this is normal, so that's why this angle should be 90 degree. And this is perpendicular upon the base plane, that means XY plane. So this angle is theta. So N is the normal to the plane, tangent plane, and K is the normal to the base plane. So between these two is called the inclination angle. So now can we go to the next page?
Yes, sir.
Okay. So as K is a normal to the XY plane. So the cosine angle between these two planes cosine angle between these two planes can be defined cos theta equal to n dot k divided by modulus of n and modulus of k, because you know that A cross B is A mod B mod cos theta. So from this relation, we can write this relation. So we know that K is the unit normal. So that's why we can write n dot K, where n is vector. This is also vector, divided by mod of n. This is the mathematical formula to determine the inclination angle of a tangent plane. Now I'm go for an example. So find the angle of inclination of the tangent plane to the ellipsoid x square by 12, y square by 12, z square by 3 equal to 1 at the point at the point 2, 2, 1. So based on the theorem at the very beginning, we should determine the capital F of x1. So what is the solution? So solution is, let capital F x y z equal to x square by 12, y square by 12, z square by 3 minus 1 equal to 0. Now determine the gradient of f. Now determine the gradient of f. Can I go to the next page? Baba, can I go to next page? Yes or no?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, so now we should determine the gradient. So to determine the gradient, of f, x, y, z, that means del f, del x, I, del f, del y, z, del f, del z, k. So del f, del x, when we are doing with respect to x, then it will be x by 6, I. When we will do with respect to y by 6, z. With respect to z, then it is 2 divided by 3 z, k, and 1 is 0. So this is the gradient of capital F. So now gradient of capital F. Now gradient of x, y, z at the given point. At the given point 2, 2, 1 is gradient f 2, 2, 1 is, if you plug x equal to 2, then you will get 1/3 I, 1/3 j, and plus 2/3 k. Any confusion? So
No, sir.
based on the theorem, we know that gradient of f at 2, 2, 1 is normal to the tangent plane. Is normal to the tangent plane, and k is the normal to the xy plane. So that's why. So if angle between the planes is theta, then we can write cos theta equal to gradient of f at 2, 2, 1 modulus divided by, based on the theorem, dot k divided by modulus of 2 to 1, because the modulus of k is 1. So that's why we escape that part. So if we multiply the gradient, what was the gradient? Gradient was this one. So if we do the dot product with k, then we will get only 2 divided by 3. Everybody, do you understand or any confusion? And if we do find out the modulus of this one, then we will get x component square, y component square, plus z component square. Any confusion, anybody? Baba, do you have any confusion?
No, sir.
Anybody?
No, sir.
Then calculate the things, then you will get 2 divided by 3. The square root of 2 divided by 3. So that's why the theta will be cos inverse square root of 2 divided by 3. What was that? Root 2 divided by root 3. Do you know what is the angle between of cos root 2 by 3? You can use your calculator. You can use your calculator. What is the angle?
35 degrees, sir.
Sorry. 35.3 degrees. This is our answer. Now I'm go for our last part. That is the comparison between gradient of function of two variables and function of three variables. So you know that gradient is in representing the normal plane at any point. So that's why if the function is differentiable and gradients are non-zero, then gradient of a function of two variable is representing the normal to the level curve. Normal to the level curve.
Excuse me, sir.
Yeah.
Sir, it's 110. 10. The class finished. I mean, it's time for
110
praying.
degree.
No. The time.
Oh, time.
Yes, sir.
Oh, time is over 1. Okay,
Yes,
so
sir.
can you consider me for more 5 minutes?
Okay, sir.
Okay. Sorry, I have used the maximum number of boards, so that's why I cannot create a new board. Okay, so listen, the gradient of a function of two variable indicating the normal to the level curve. Normal to the level curve, and gradient of the function of three variable indicating the normal to the level surface. That means one is normal to the level curve and another one is normal to the level surface. Which one is normal to the level surface? Which one? Which one is indicating the normal to the level surface? Marine, are you here? Everybody, are you here?
Yes, sir.
Function of three variables. Gradient of function of three variables indicating the normal to the level surface. And gradient of function of two variables indicating the normal to the level curve. This is the difference. So you will practice from the exercise 13.7, 6, 11, 18, 22, 26, 30, 36, and 40. So inshallah, next class we will show the how to determine the maxima and minima for function of several variables. So now can we conclude our lecture for this day? Yeah.
Sir,
Sir,
can
can
you
you
please
please
repeat
repeat
the
the exercises?
Any question?
Sir, can you please repeat the exercise numbers?
Oh, exercise numbers. Baba, it is given in my slide also. Maybe slide is given in your classroom. Again, I am telling number 6, number 11, number 18, number 22, number 26, number 30, number 36, number 40. Is it okay?
Okay, thank you. Yes, sir.
Okay, so now can we leave?
Yes, sir.
Okay, thank you very much for your participation. Inshallah, in the next class, we will meet physically.
Inshallah, sir. Assalamu alaikum.
Walaikum assalam.